Hey everyone, this is the part 2 of my chapter 20 notes walkthrough for week 5, Bio 101. Remember, you can find this Word document in the week 5 questions thread under the My Notes post. Okay, so we left off right here. So I just want to talk a moment for charismatic megavertebrates. These are really cute, adorable, really big critters. Think of elephants. You could even just go koalas, whales, anything that you typically will see on a nonprofit symbol or seal because they're cute and people will spend money to save them. And usually they're up at the top, so they'll help a lot. Did I scroll down too far? I like to scroll down too far. It makes me happy. Nope, I didn't. All right. Disturbances. These are episodes that damage biological communities, at least temporarily, by destroying organisms and altering the availability of resources such as mineral, nutrients, and water. Examples of natural disturbances can be storms, fires, floods, droughts, but humans are by far the most significant agents of disturbance today. Habitat destruction may also cause pathogen-carrying animals to venture closer to human dwellings in search of food. I did an example of jaguar. You can look at eHow, that has a good thing, but jaguars that are shot have a harder time hunting, so then they end up trying to go after cattle and other easy-to-get prey, even though they would prefer to eat their normal prey. So disturbed area may be colonized by a variety of species, which are gradually replaced in a succession of other species. This process is called ecological succession. We talk about this a lot with forests, typically, right? When ecological succession begins in a virtually lifeless area, so say there was a volcanic eruption, think Mount St. Helens. There is called a primary succession. Examples of such areas are cooled lava flows from volcanic islands, the rubble left by a retreating glacier. Often the only life forms initially present are going to be autotrophic bacteria. Lichens, mosses, which grow on wind-blown spores, are commonly the first multicellular photosynthesizers to colonize the area. It depends on how big it is, right? Did you take out the chunk in the center of a forest, or did you take out like an entire mountain? Soil develops gradually as the rocks weather and organic matter accumulates from the decomposed remains of the early colonizers. Lichens and mosses are eventually overgrown by grasses and shrubs that can sprout from seeds blown in from nearby areas or carried in by animals. Finally, the area is colonized by plants that become the community's prevalent form of vegetation. Primary succession can take hundreds or thousands of years. So my example is the Anasazi that lived in the southwest. They denuded their entire area, so now it's a desert. So we don't know when that will return back to the forest that they lived in. The Mayans, when they were around, all of Belize and a lot of South and Central America was stripped down to nothing because they were growing crops and food, but now it has mostly recovered until recently. That's okay. Secondary succession occurs where a disturbance has destroyed an existing community but left the soil intact. So we're not starting with nothing, we got some dirt. For example, secondary succession occurs as areas overcome floods or fires. Disturbances that led to secondary succession are also caused by human activities. Even before colonial times, humans were clearing and the temperate deciduous forests of the eastern North America for agriculture and settlements. Some of this land was later abandoned as the soil was depleted of its chemical nutrients, or the residents moved west to new territories. Whenever human intervention stops, the secondary succession begins, assuming we don't destroy it down past the dirt, right? And there's a link to define what that is. Succession. Okay, so on ecosystem, we've already defined it, but let's do it again. Just to remind us, it's the abiotic factors as well as the biotic factors. So in summary, both energy flow and chemical cycling involve a transfer of substances through the trophic levels of the ecosystem. However, energy flows through and ultimately out of ecosystems, whereas chemicals are recycled within and between ecosystems. So the amount of mass of a living organic material in an ecosystem is called the biomass. So all the organic stuff, how much it weighs. And then the rate at which the ecosystem's producers convert solar energy to chemical energy stored in biomass is called primary production. The primary production of the entire biosphere is roughly 165 billion tons of biomass per year. Different ecosystems vary considerably in their primary production, as well as in their contribution to the total production of the biosphere. Because some places are going to have lots of animals and some places aren't. Even though the open ocean has very low production, it contributes the most to the Earth's total net primary production because of its huge size. It covers 65% of the Earth's surface, right? So it's also like, where is all this stuff happening? The pyramid of production illustrates the cumulative loss of energy with each transfer in the food chain. So you don't get, like, if you eat a plant, you're not going to get all the energy that it created, right? Because it used some of its own. And then if you eat the herbivore, same thing. You don't get all the energy it got because it used some for itself. Eating meat of any kind is both economically and environmentally expensive. Producing meat for humans' consumption usually requires that more land be used than for growing grain, which means greater use of fertilizer, pesticide, and water for irrigation. So this is kind of negative on the meat production, but it depends on what you're eating, and this is a very complicated, very complicated decision. You do a lot more research than one source if you decide to use this as a basis to become a vegetarian. Though in general, we should all eat a lot more vegetables. Chemical cycles in the ecosystem involve both biotic and abiotic components, right? They are called biogeochemical cycles. And there's a good video. I think it's a video. It's probably not a video because it's a chapter. So there's a good little article. So we see how stuff works in the abiotic is what we are, or in the biotic, blah, blah. Here's how stuff goes in the biotic. And then in the abiotic reservoir, it's also going to go through a geological process. So like water, how it cycles, but then how it also goes through the animals or organisms. When I'm saying animals, I mean colloquial. So they talk about the carbon cycle, the phosphorus cycle, and the nitrogen cycle. Here are some really good videos. It's just the best way to go through this stuff, right? Basically, just know that these cycles exist and that we're all part of them and we don't want to mess them up. An example of how far-reaching this problem can be, nitrogen runoff from the Midwestern farm fields has been linked to an annual summer dead zone in the Gulf of Mexico. Now, this is probably not taking into effect the oil spill, right? That happened, when did that happen? Like 2012-ish? Vast algal blooms extend outward from where the Mississippi River deposits its nutrient-laden waters. As the algae die, decomposition of the huge quantity of biomass diminishes the supply of dissolved oxygen over an area that ranges from 13,000 kilometers squared, roughly the size of Connecticut, to 22,000 kilometers squared, about the area of Michigan. Oxygen depletion disrupts benthic communities, displacing fish and vertebrates that can move and killing organisms that are attached to substrate. So if you can get out of the way, you do. If you can't, you're dead. More than 400 recurring and permanent coastal dead zones totaling approximately 245,000 kilometers squared have been documented worldwide. This is a very big issue. It can really mess up not just the environment, but like if you want seafood from this area, it can be a big problem because it's all moved or dead. Conservation biology is a goal-oriented science that seeks to understand and counter the loss of biodiversity. Conservation biologists recognize that biodiversity can be sustained only if the evolutionary mechanisms that have given rise to species and communities of organisms continue to operate. So conservation biology is how do we protect and conserve. We know that the environment itself does change because that's how evolution happened, but we don't want to do undue pressure. Biodiversity hotspots, these are relatively small areas that have large numbers of endangered and threatened species and an exceptional concentration of endemic. Those are species that are only found in that area. Together, the hottest of Earth's biodiversity hotspots total less than 1.5 of the Earth's land surface, but are home to a third of all species of plants and vertebrates. And there's a good little link. If you were in class and I was doing a lecture, I would show you all the links. Ecologically, a landscape is a regional assemblage of interacting ecosystems, such as an area with forests, adjacent fields, wetlands, streams, and streamside habitats. Landscape ecology is the application of ecological principles to the study of land use patterns. So how do we keep all this land happy and healthy while still getting to use it, right? Think sustainability. Another important landscape feature, especially where habitats have been severely fragmented, is the movement corridor. This is a narrow strip or series of small clumps of suitable habitats connecting otherwise isolated patches. So you have a bunch of random dots. How do we connect them so that everywhere has more space, but still make the corridor so that predators don't just sit on the side and kill off prey? So we want to make it safe to move between the areas. This is a big issue in California and other places with like mountain lions are coming into populated areas because they have no corridor. They have to get between. Bioremediation is the use of living organisms to detoxify polluted ecosystems. So there's lots of bacteria that work on old mining sites and oil spills. And we've got, let's see what's on this one. I'm going to let you read that one. Yourself. Sustainable development. This is our big word, right? The Ecological Society of America, the world's largest organization of ecologists, endorses a research agenda called Sustainable Biosphere Initiative. The goal of this initiative is to acquire the ecological information necessary for the responsible development, management, and conservation of the Earth's resources. And here's a good link. So basically, how can humans still do what they want to do without totally fucking up the entire globe? It's always a goal. Okay, so we ended on a nice depressing note, but the big thing to keep in mind is like, in the past, humanity killed stuff off, especially with the Industrial Revolution, because we got a heck of a lot better at it. And now we've woken up as a society, a culture, an ecological niche, and we're trying to figure out like how do we keep what we have today and encourage it to thrive while still getting to do the stuff that we want to do. Is there a compromise? Is there a place where, you know, elephants can exist in the future without us shooting them for the ivory just because we think it's pretty? Like, where can we find this happy medium? I hope this helped you to understand this information a little bit better, and look forward to being depressed when you read the entire chapter. Enjoy!